Hello everyone, welcome grade 8 and welcome to your geography lesson this week. We are in week 3. I hope everyone is fine. Okay, for this lesson, you only need the following. You need your geography book, geography copybook, and your pencil. Alright, we usually start by the learning objectives of the lesson. The topics that we're going to cover in our lesson and that most of us or all of us should know or learn today. So everyone should understand the formation of river landforms such as waterfall, meanders, and oxbow lakes. Also need to be able to know the Bradshaw's model of river investigations. And this is all by the end of the lesson. Okay, here we go. We start by the revision of the concepts that we had in geography last time. Previously, we learned that rivers erode, transport, and deposit materials throughout its journey from source to mouth. And then what is meant by river erosion? And we said it's the wearing away of the river's bed and the side of the channel by force of flowing water. And what is deposition? Deposition is when the river losing energy and it has no longer enough energy to carry the materials that it is transforming, so it deposits these materials, and heavier materials are deposited first. What's a long profile of a river? It's the investigation of a river's landforms from source up to mouth. So this takes us to take the landforms as our topic of investigation in a lot more details. What are waterfalls and how are they formed? Maybe all of us or most of us have seen waterfalls in real life. They are beautiful. But what is more beautiful is the beauty behind this. It's the science, how this all came to paint this nice picture of the nature. Waterfalls form the steep drop along profile of a river where the water is actually flowing between two different rock layers. One of them is harder and the other is softer. So the water hits the hard rocks against the softer ones, causing it to be eroded and transported, and this leaves like a deep hole in the base of the waterfall we call the plunge pool. And this process of undercutting on the softer rocks are actually causing larger, harder rocks to collapse, and this actually what makes the waterfall retreat upstream, because it is losing its grounds by the force of erosion that is happening. Okay, and this leaves a place we call the gorge. It tells you that the waterfall was here before it retreated up to the river. So we have harder rocks, softer rocks, undercutting happening here. The water pushes the harder rocks against the softer on the base of the waterfall, and this actually causing this deep pool we call the plunge pool. Okay, now comes to the second topic, how meanders are formed. Look at this diagram on your right hand side. You look at the river in its long scale. Look at this kind of bends that are happening throughout the course of the river. So meanders are bends actually in the course of a river. The outsider side is actually deeper and the water is flowing fast, while the inside the water is shallow and slowly moving, and this is actually creating something called river cliff on the outer side because of erosion. The inside the water is very slow and the river deposits its fine materials and the materials that it is transporting. Okay. What happens if the erosion becomes too extreme on the bends? You can look at the diagram, look at the bend. If there is too much of this erosion, the two bends will meet at some point, and the water will take what straight line, leaving this new shape of the landform we call the Oxbow Lake. So the two bends get closer to each other because of erosion, and the water takes a straight way, making this Oxbow Lake beautiful. All right. Bradshaw's model. Okay. We know that in geography, like rivers are not alike, but they actually share certain characteristics. These characteristics are actually the focus of scientists or geographers. And we have Bradshaw. Bradshaw is one of the geographers who are interested in studying and investigating rivers, and he dwelled on these common characteristics, and he worked out this diagram or model to help geographers study rivers all around the world. So as you can see, the discharge or the channel depths, the velocity, which is the speed, the load quantity, speaking of materials, are all increase downstream. You have upstream and downstreams, they increase, while the load size, the bed roughness, the gradient, and the degree, and the gradient are all decreased downstream. Okay, the 7, like what does that mean? If we take a look at the width of the channel, in the upper course of a river, the channel is wide or narrow? Yes, it's narrow, it's not wide. So this width increases when you go down, it increases when you go downstream. That's it. Okay, the same as the velocity, the speed. It gets quicker in the upper or in the upper course of the river. The 7 steps of conducting a field work. To actually test Bradshaw's model, geographers have to put these theories on practice in real life. And by doing this, you need to go on a field work. So let's take a look at the steps geographers follow to do their field work. We have 7 steps. First, you need to create your inquiry questions. Do you think like an inquiry question can be any kind of a question? No. These are questions that are based on observation. And if we find answers to them, we will add up our knowledge. So write down the questions you need to answer. Select your fieldwork location using an OS Maps. Why? Because they are accurate and they are easy to use. Collect your data, and you collect your data by measuring the width, the depth, and the speed of the river. For the width, you can use a measuring tape, and for the depth, you can use a kind of a ruler, special kind. For the speed, you can use any floating object. You determine a point, or you determine a certain space on the river side, and then you put your floating object like a toy or an orange, and then you calculate the time, how much of a time does it cost this piece of orange or this toy to travel from a certain point to the other. And then you have speed. In physics, we have speed equals space over time, right? Or distance over time. By doing this, you will know the velocity of the water. You need to do this 3 times to get more accurate results. Okay, you need to collect your data. That's collecting data. And then you need to present your data on tables or graphs, like value equals numbers. You can say the depth is so and so. The width is, let's say, 2 kilometers, let's say, as an example. You need to analyze your data using the graphs to show the width, for example, and reach your conclusions by answering the inquiry questions you set at the beginning of your trip or your field work. And actually these answers are to be supported by evidence, the evidence that you collected through your observation. And you need to evaluate your field work and the results. Are the results accurate? Tell what the field work was carried on, and what kind of measurements did you use, and how the field work was carried out, and were the readings or the measurements accurate? What could you do to make this investigation more accurate? You need to put all this information so that it can help other researchers or other geographers to come and work on your findings. Okay, that's Bradshaw's model in general. Okay, to recap, what's a waterfall? What are meanders, and how are they formed? Why do we have to use Bradshaw's model? Answering this will help you actually to understand these concepts. Okay, you need to do activities on page 111, question 3, A, B. And don't forget to do your homework on your geography workbook, pages 10 and 11. I'm looking forward to receive your work. Bye for now.